Hi, everyone. How are we doing? Happy to have you today. Be sure you're signing in. There should be the yellow sheets back there so you can get credit for this course. So it's nice to be here with you all today. This is the first time I've been asked to speak at this conference. I'm relatively new to WSU. This is in January. I would have been here for 2 years. So I'm my subject matters within produce safety. So all things food safety that come up, feel free to contact us, as well as working with your local extension faculty to help, kind of build robust food safety programs. I know that berries have seen a bit of a shakeup, especially over this past year with increased scrutiny from the FDA and sampling. And so we thought it would be a nice thing to go through some of the risks we've seen associated with berries, what we can learn from that, and to help teach you all a little bit about some of these organisms so that in essence, you can better learn how to control for them and learn what their ultimate risk is. So, my slides kind of got moved around a little bit, but so excuse that. But essentially, I like being a microbiologist who works with just foodborne pathogens because I am just right down here. I'm this little tiny sliver here of all the organisms. There's so many organisms out there. Some make people sick, not in foods. Others will just spoil food, which is a big issue for us, right? We don't want to have a lot of spoiled product out there. Others we use for good stuff like fermentations. But really what I specialize in are foodborne pathogens, or those organisms that can make people sick if they eat them and they're present on foods. To start kind of big and then go down smaller and smaller, when I think about microorganisms, I'm thinking about 5 different groups. So I think about bacteria, I think about molds, I think about yeast, and then viruses and parasites are my big, large buckets that I put these organisms in. For a little bit more kind of gradation between these, we can see that as far as organisms which are readily involved in spoilage, which at the end of the day can really drive, for especially our fresh markets, a ton of loss for us, right? We're going to be looking at things like bacteria. Lactic acid bacteria can really ferment things very nicely. Molds, of course, are a big issue in a lot of our fresh berries. And then yeast as well can rear their ugly heads. Viruses and parasites, not so much as far as spoilage goes. When we think of things that I work with that can actually make people ill, again, foodborne pathogens are fancy 10-cent word for that. We are really looking at just the bacteria group and then also viruses and parasites. So notice we dropped molds and yeast out. And I think for sometimes people, if they're wearing the compliance hat, spoilage is important, right? Because you try and deter it. But at the end of the day, spoilage causes quality issues. It doesn't cause food safety issues. So it's always important to keep that, even though a lot of times you are wearing the quality and the food safety hat all together. But as far as regulatory implications, it's really totally different. Amongst these, the thing as a microbiologist that, especially if we're working with organisms that can make people sick potentially, kind of the worst case scenario is if the number of organisms actually increase, or if they're able to increase over time. So there's only a few organisms that are capable amongst this list of doing that. So this are our bacteria and our molds and our yeast. So really amongst things that can make people sick, it's only bacteria which can actually grow in the environment. When I say grow, I don't mean get bigger and bigger. I mean increase in numbers. So when I talk about the environment, that's our growing field, right? That's our produce. That's going to be the water, the soil. These organisms are capable of growing within that environment. And amongst those, bacteria are the ones the group that could potentially make us sick. Notice viruses and parasites are not part of this group. And I think that's really important to keep in mind, because while a contamination event can happen, a virus gets on raspberries or something along those lines, the number of what we call virus particles is never going to increase. And why that's important is because a lot of times the dose does make the poison. So the more organisms that are there, the more likely you are to have people actually getting sick. So conversely, we have viruses and parasites which cannot grow in that field environment. But it's always important to remember, while they can't increase in numbers, they are very capable of surviving extremely long periods of time. So they're relatively stable once they land on something. They're just kind of hitching a ride. Now, how do they make us sick? Essentially, once we consume them, they then act, probably the virus we're most familiar with is like the flu, right? Once it gets inside of us, then again, it can start to replicate. And then that's ultimately when we get ill. Same thing for parasites that can happen there. As far as where do these organisms come from, they come from the environment. So that is air, water, and soil. They can also come from plants. So ultimately, that's what we really try and safeguard against. So that's, inputs from soil, right? Soil amendments, if you're using raw manure or something along those lines, or just the fact that once soil becomes contaminated, it can be a pretty stable environment. Irrigation water is always, and not even beyond irrigation water, the water used for your sprays, of course, all of these things can be a source of contamination. Animal feces, of course, has been attributed some linkage to amongst various really strawberries in the past, but even something as small as a fly ultimately can be a vector. At the end of the day, we try and deter what we can, but there is a point at which you're not getting a good return on investment for controlling there. So don't drive yourself crazy. As far as animals go, again, there's been a large historical link to animal foods being attributed essentially from their feces contamination. So this comes from meat and also can be seen in eggs and in milk products though as well. So things beyond this kind of growing environment or the food itself, we have people, right? So people ultimately can both be shedding some of these organisms, and again, it's kind of gross. We call it fecal oral contamination routes. But again, they're shedding these organisms in their stool. They're then, even if they wash their hands, there's been studies that Dr. Leanne Jacobs will probably allude to, if someone is shedding something like norovirus, even if they're the king or queen of hand washing, it's very likely they're still going to have norovirus on their hands after they go through that event. So really having good ill worker policies in place to try and preclude them from even touching your product. And also knowing that a lot of times in food service, when we see things go down, this can be one of the primary areas of ill food handlers. But it's not something the processing world's totally immune to. Especially when we're thinking about things like hand harvesting and things along those lines. Again, food contact surfaces are a really important thing. So, and things that would fall in this are like your mechanical harvesters, right? And of course, anything we're doing on the post-harvest side as far as manipulating that crop in IQF, or even if it's being turned into a puree or something along those lines. Cross-contamination, again, can be one of the biggest issues that we see for contributing and expanding contamination. So you could have a point source contamination, and that will implicate a small amount of your crop. But essentially with cross-contamination, you take a small problem and make it a big problem. And this a lot of times happens as equipment moves through a field or as people move around, right? And that's even the equipment that we use, like if you're using something like forklifts and things along those lines, these have been shown, if they aren't being properly sanitized, to be a potential source of contamination. Even though you think about forklifts, like, well, that's not actually contacting the fruit, but it's manipulating all of the other things. One of our biggest things is contaminated product coming through at a point source, like for harvesting, for instance, and that spreading to uncontaminated product. In fact, we've all seen the rash of romaine outbreaks going on over the past couple of years, right? They've actually gone through done a pretty nice study where they can have a point source contamination event out in that field. And as they go through the field harvesting, they are basically spreading that contamination through a lot of the crop that they're packing out. So, and when I say contamination, people are like, well, I should be able to see that. And not always. I mean, these things are invisible, right? That's why we call them microorganisms. And when it's something like animal feces, yeah, you can identify that, but sometimes it's not that clear cut. So as far as what makes people ill in the United States, we have metrics that the CDC comes out with. And so our most recent metric It's 48 million people in the United States every year get sick from a foodborne illness. We were at 72 million, so we're definitely coming down and moving in the right direction. But what that equates to is roughly 1 in every 6 Americans every year gets sick from one of these foodborne pathogens. That equates to almost 130,000 hospitalizations, and of course, worst case scenario, about 3,000 deaths every year. When we think about what's really driving these numbers, what are some of these organisms that are actually strongly linked to people getting ill? The ones that we, and again, I've put these into our same buckets. So we have bacteria up here up at the top, and then we have parasites, and then we have viruses down here at the bottom. So I've highlighted there in orange the organisms which are most commonly associated with produce, but even more specifically with small fruits. So are berries. And what we have as we go through the columns, for instance, with something like Salmonella, we're looking at roughly 1.3 million or 1.2 million people getting ill every year with salmonellosis. Of those, we have about 23,000 that actually have to seek hospitalization, and then we have a death rate of roughly 0.5%. Now, as you can tell, these numbers vary widely across these organisms. For instance, the frozen food world has been really rocked by Listeria recently, right? As they start to investigate more. And I would say that a lot of this stuff, while it's making the news more recently, it has probably been happening all along, right? They just weren't looking for it as intently or trying to determine what was making people ill as much. And when I say that they, typically it's the FDA doing those sorts of investigations. So for instance, you would look at something like Listeria, which causes a huge amount of recalls. If you follow recalls, and a lot of you are the food safety people, so you're doing that regularly, you will notice it's like, well, only 1,600 people get sick every year. So what's the big deal? Why all these recalls? What else do you notice though that kind of makes this one stand out? What's the big difference there? Yeah, high death rate. We're talking about a near 16% death rate amongst people who get ill. And that's why, from a political standpoint, yeah, you have to come out with really strong regulations, because inevitably, if people are dying from this, then we need to take strong and swift action. Now, from a policy debate, we can say, are zero tolerance policies actually resulting in fewer people getting ill? A lot of the data says no, but it's not just politically advantageous to change the laws so that we can work around trying to get reduced incidence. For parasites, a lot of times, again, I work with bacteria, but with parasites, a lot of times we'll gloss over them almost, but for you all, you need to start digging in and really learning the parasite and virus game, because it's going to be shaking up this industry quite a bit. And so amongst small fruit and berries, cyclospora tends to be the parasite that we see most commonly associated with berries. You'll see there roughly 20,000 people every year getting ill. But essentially you may get ill, but we don't have a high death rate associated with it. For viruses, norovirus and hepatitis A are both very important for you all. So you can tell that both of those are not similar as far as their incidence. Norovirus is the 100-pound gorilla that is coming after, and really our biggest cause of foodborne illness. Now, of course, a lot of this is not associated with berries, but when we have seen outbreaks before, we do have a stronger incidence with norovirus. Hepatitis A, while again, we don't see the same incidence of people getting hepatitis, it does have worse health outcomes, right? And hepatitis is also a bit of a bear because it can have what we call an incubation period of roughly 40 days. This means an ill food handler can be shedding this virus, and it's essentially 40 days before they even start to show symptoms. So that's an incredibly long time compared to many of these things. It's like a day to maybe 3 days at most. This is data looking at the reportable food registry. So when the reportable food registry is basically where if I'm a food manufacturer and I conduct a recall, I have to go into the reportable food registry and enter in why that recall occurred. So we can see here that this is undeclared allergens. So that really doesn't involve you all unless you're making more complicated products. So like a product that contained milk that didn't say that on its label. But we see that as far as recalls go, for microorganisms, it's Listeria monocytogenes, causing roughly nearly a quarter of all recalls, and then Salmonella pulling up right at a quarter of all recalls. And this is data that was compiled over a 5-year period, so it's pretty indicative of this is what's actually people are taking based upon a lot of times you're initiating a recall, not because people have gotten sick. Most commonly, that product's tested at some point, either by someone you're selling that product to or at retail, and then they're coming out and saying, oh, we got a hit, and they're letting you know as a person who sold that product, and then you initiate the recall. This was data looking at how the percent of food groups that were within these categories. So we have here fresh cut produce, was one that I was trying to highlight. We also have fresh produce, which is actually not showing up at all right here, but that's what that bar was. And then we're looking at Salmonella is the blue line. And as I was saying, if we go in and look at the foodborne pathogens, like notice parasites, viruses, weren't even on that list, right? They're not even showing a blip on the radar. But when we go in for produce, raw commodity produce, what we're seeing is first Salmonella, and then secondly, Listeria monocytogenes. For fresh cut, we're looking at the inverse, where Listeria is more of a risk. Again, that product's held at refrigeration. We'll learn a little bit about Listeria and what makes it special. Fruit and vegetable products are another category that are kind of non-frozen produce, that where fruit or vegetable has been integrated as a primary component. And then we have our frozen foods, which for many in this room, they're like, well, we're doing pretty well, right? This is not really showing a huge issue there. And typically Listeria is more of an issue in frozen. So yeah, I'm glad this is working. So for our berry specific outbreaks. Now again, an outbreak is where 2 or more people have gotten ill from eating the same food product. I went back over a decade and looked up every berry outbreak I could find, and this is what I came up with. So the first thing you'll notice, and this is not involving recalls at all. So the first thing you'll notice is that we have a fairly low case count, right? We're sitting at about 400, a little bit more than 400 cases collectively over a decade. What you'll notice is that as far as bacteria go, E. coli 0157 and a bit of Salmonella has been implicated in the past. You'll notice though, primarily we're looking at Norovirus and Hepatitis A and a bit of Cyclospora popping up in there. You'll also notice that while berries are grouped all together, really this has been more so initially implicated with strawberries, more so than maybe some of our mixed berries or some of our frozen berries. If there was a cause implicated, I tried to capture that in this last category. So for instance, this top one was basically a banquet event. The food handler was ill in the banquet community, so it didn't come from the farm level. But other things, essentially this fresh strawberry, where we had deer contamination in the field, that isolated the same genetic fingerprint back to that E. coli. And so that's a clear on-farm contamination event. But a lot of times we don't know where contamination is coming in, because simply this product is being sampled either in the distribution system at the very end, right? So you're not sure quite where this contamination entered in. Dr. Jacobs will speak more to this, but as a result of observing this high association with norovirus, hepatitis A, as well as parasitic infections, the FDA announced last year that they would be beginning a frozen berry sampling. Now, these are special projects that are done so the FDA can basically poke around and figure out what may be causing some of these illnesses. They're going to collect a total of 2,000 frozen berry samples. They're going to do both domestic as well as imported. They're going to be testing just for viruses, norovirus and hepatitis A. Historically, viruses are really tricky to test for. We rely upon molecular mechanisms to test for them. And in foods, a lot of times you're dealing with a very low contamination level. So the methodology is improving there, but historically they're not as easy to detect as bacteria are. Sampling began in last year. I think you're all pretty aware of some of the fallout from that sampling. Know that it's continuing on. The one thing the FDA has changed is they've stopped pulling product at retail, so that in essence, they stop disrupting and initiating a recall, right? So they can essentially sample at the distribution system, or even better, one step up as far as the manufacturer, let you hold that product. If it does come back positive, then you can essentially not put it into commerce. We'll hear more about this from Dr. Jaga, so I don't want to steal her thunder. So I wanted to give you all a really brief introduction in the remaining time as far as some of the things we think about from food safety. My goal is to make you all better arguers when it comes down to justifying why you've done certain things in your food safety plan, and just give you some information basically so you can substantiate why you're doing what you're doing and help better answer questions that may pop up. Because we like to think of, you know, auditors and inspectors as all-knowing people. At the end of the day, they're people just like us, and they may move between many different commodities, and what's important in one commodity may not be at all important for you, and it's important for you to know kind of some of these nuances that make it really important for you. So when we hear about an outbreak, that means people have actually gotten sick from consuming a food product. Now, a lot of us have this misnomer that when there's an outbreak, they always find out the whodunit. And at the end of the day, the vast majority of the time we do not know, right? People get sick and they never are able to track it back. So when one person gets sick, that's what we call a case. That's why you saw case counts there in that chart I just showed you. When we actually have an outbreak is when more than 2 people get ill from consuming that same food product. So what do we have to have? Well, if I was developing a food safety plan, I would look back at historical association. So that chart I just showed of small fruits and contamination and outbreaks, right? Also, I didn't capture recalls, but also looking at recalls that have come up over the past couple of years and looking at trends there would be important for identifying what's the biggest risk for your food safety plan. Also, looking for bacteria, what's the likelihood of growth? If I can basically stabilize things, keep them at refrigeration, I will slow down bacterial growth. In some instances, I arrest it altogether. Always with frozen, you're not going to have any bacterial growth, right? So that's an example there. But essentially, if you create the perfect storm and you give these organisms an opportunity to grow, then the more organisms that are there, the more likely you are to make people sick and a greater number of people sick. And then ultimately they have to survive however they're going to be fixed, right? So, you know, potatoes are grown in the ground. They're exposed to all these organisms, but yet we don't have outbreaks of potato associated with potatoes, right? It's because everybody's cooking them. So cooking is going to be one of our best inactivation steps, but unfortunately we do like eating berries a lot of times fresh or fresh frozen. So that's not going to work for us. But no, if you do have that kill step, and heat is our favorite kill step, then that's going to give you an added layer of protection. And if you as a processor actually apply that kill step, it's a lot better off than relying upon the consumer to do that. We just got done with Thanksgiving. How many people even use a thermometer to cook their turkey, right? So that shows how things can break down really easily. And then ultimately you have to have consumption of the food. And thank goodness for us, a lot of times our spoilage organisms take off and they actually make the food gross, right? Like, so it's not going to be contaminated to a level that, you know, people stop eating it basically. So sometimes that works in our advantage, but that's really more so for meat versus produce. The next thing we ask ourselves is, there are like 1,400 different types of salmonella. Not all salmonella are created equally. So when we think about trends, for instance, cyclospores are a really good example. While it may make you sick, it doesn't have the same incidence as far as making people die, right? So there may be gradations in how we treat some of these risks and the length we go to, because inevitably you're trying to reduce liability for your farm and your operation, right? So looking at liability as worst case outcomes, death, you know, hospitalizations and having large scale multi-state outbreaks would be the things that I would focus most of my food safety resources on, because none of us have bottomless pocketbooks. The other thing you have to think about is, who am I feeding this to? And I like to call this the susceptible individuals, but I call them YOPIs. It's young, old, pregnant, and immunocompromised. Those people are more commonly getting ill from a foodborne pathogen. And I would say this really comes more so into play if you're making a specialty product. For instance, something that's going to hospitals, like hospitals and things along those lines. You would maybe want to think of applying an extra processing step to get a good kill step in for those types of products versus feeding fresh to those individuals. And then lastly, we have to have recognition, right? So I would say viruses and parasites a lot of times go flying under the radar. And one thing that's really shook up the medical community as far as our ability to be able to actually diagnose these things is that they've moved to what they call culture-independent diagnostic testing, which is a molecular-based approach where they can test when people are getting ill and ultimately, through a molecular match, find out what's most likely causing them to become ill. So they'll test a stool sample, for instance, and they can easily now screen for parasites. And we've seen our parasite count go up quite a bit since this has come in favor over the past couple of years. So I would say you're going to start to see maybe more focus there as the regulatory agencies then start responding. Oh, not last. Documented by medical personnel is also important. A lot of times you go to the doctor, you're having GI upset, right? They're just going to treat you, and they may not ever even get a stool sample from you, right? So it's really when we have worst case outcomes, people getting hospitalized, ultimately a lot of this may fly completely under the radar. So this is my pyramid, and I think this helps frame things, because I talk to a lot of growers, a lot of processors, and they're like, our products are safe, or my farm is safe. We've never been involved in an outbreak or a recall. And I was like, well, don't rest on your laurels too much there. I would take much more stock in the programs I've developed, because in reality, it's kind of like a needle in a haystack when it goes into getting these cases documented. So what has to happen is that first you have to eat the food, right? And then a certain percentage of us may come down and actually become ill. You then have to get ill long enough that you actually go to the doctor. A lot of us are just going to wait it out. It's a stomach flu, right? And we're going to see if it passes after a day or two. So you go to the doctor. They a lot of times do not obtain stool specimens. People are also really weird about giving specimens like that. So they have to get stool many times to diagnose these things and to do their diagnostic testing. That lab then reports back out. If the stool specimen tested positive, that then is tracked as a laboratory confirmed case. They will report that to a health department at the county level. Sometimes it's regional. And then what happens is that health department individual will make a judgment call. There are tons of things reported to them every day, and they simply do not have the resources to track them. What they're looking for is case history over the past couple of weeks. And once they start to see the number of cases tick up, then they actually start to reach out to those people. And what they'll do is they'll say, hey, Faith, we noticed that you had gotten ill. We got that report from your medical professional. We want to talk to you about what you ate over the past 10 days before you got sick. Like, can y'all remember what you ate 4 days ago? Matter less, like 2 weeks ago. So you have to get enough people reporting in before they can even start to hypothesize from the epidemiology level what foods may be implicated in making people sick. That's why we're really great at determining outbreaks that happen from what I call a controlled feeding. So that's a banquet, or if you have a school system, or if you have like a prison. I think is a really good example of how we're really good, because we know what we're feeding those people. We give them like a menu and they tell us what they picked. Otherwise, for the rest of us, a lot of things get lost in the wash. And a lot of food products are commingled, right? How many things are berries mixed with regularly when they're eaten? It's never just people living off of blueberries and raspberries. And even then parsing it out like, well, was it the blueberry or was it the raspberry? And really trying to get down at what's causing this. at the end of the day, the health departments then upload this genetic data to the CDC, and then the CDC is looking at the national level from surveillance and determining, do we have a multi-state outbreak going on? Once a multi-state outbreak is recognized, then you get federal resources pulled in. So it's going to move from the state level all the way up to the federal level, and that would mean switching basically from WSDA to potentially FDA coming in and doing a for-cause investigation. Sorry. Maybe that, okay, spacebar. So again, CDC is who actually tracks what's making people, and they do way more than just foodborne pathogens. We have a couple of mechanisms for looking at that. I'm going to talk to you a little bit about bacterial foodborne pathogens. I know I've just sat up here and told you how important viruses and parasites are, but our next speaker, Dr. Jacobs, she is a parasitologist and also a virologist. She's going to be really great at filling you in on some of those things that are going on. And she's actually really engaged with the berry industry right now, especially on the frozen side, and trying to come up with a response for this. So as far as our first organism, I'm going to talk about E. coli. E. coli is essentially going to be found in warm-blooded animals. And they're their biggest reservoir. So a lot of times it's going to be cattle, pigs, moving these organisms around. But, you know, all of us cannot pick where we farm at, and our neighbors have cattle, or you may have even densely populated cattle operations, or any other livestock sort of operation. And essentially, these have been identified as a point source for contamination that can make its way into produce, either from carryover from wind or from contaminated water. So amongst E. coli, there are a ton of E. coli groups out there. And so, for instance, you may test your water for what we call generic E. coli, right? And that's an indicator of basically fecal contamination. Now, if we look at the big family of E. coli, the ones that make people sick are what we call enterohemorrhagic E. coli. You may also hear this term Shiga-toxigenic E. coli, but just to make life even harder, we like to talk in alphabet soup. So a lot of times we'll call these EHEC or STEC. And if you hear that, know that that's the type of E. coli that makes people ill in food products. I want to give you all a little bit of information because I told you bacteria can grow, right? So here's like some of our growth characteristics. Where they really like to grow is between 86 to 107. You'll notice for all these bacteria, they're adapted to surviving really well inside of us. So they like 98. A lot of times they're optimal. And when I say optimal, under these conditions, if they have nutrients available, they are doubling every 20 minutes. Right? So a lot of times it is imperative to not be in that optimal temperature range, right? So on the high end, if we have heated equipment, we try and operate it above 120 a lot of times, but it's because as long as we get above 112 for E. coli, we're not going to be able to have growth. Again, on the low side, a lot of times you'll see it's actually quite low. And I would say, well, we say 46 to 50 is their low point. At that temperature, they are really dividing very, very slowly. And you may see what took 20 minutes optimally will now take roughly a week to get to at that temperature. So time also plays a big role here. As far as heat resistance for anyone, heat processing, here's a bit of heat characteristics. These D values are basically the time it takes at a specific temperature to reduce the population by 90%. So if you're doing juice products, you're used to doing the juice HACCP rule, which is a 5-log inactivation. It's 99.999%. But these are the data that we collect as food microbiologists so that we can tell you what's the optimal heat process. So if you're doing heat processing, make sure you have your D values in your back pocket for the organisms that are of interest to you. For E. coli, it survives freezing really well. It's how we optimally store it in the lab setting. So I have my library of Shiga-toxigenic E. coli, and we put them in a little glycerol mixture, and then we stick them in the freezer, and they are nice and happy for quite some time. So freezing's never going to be a kill step for these organisms. As far as pH goes, they are rather robust as far as growth goes, and they can grow all the way down to 4. Know, though, that even once you get below 4, they're not necessarily dying, right? But they're just not growing. So here's a list of foods we have implicated. I would say the romaine lettuce people can tell you a lot about this organism right now. We've definitely seen it rear its ugly head. As far as berries go, it's really that strawberry outbreak was the biggest one, and that was directly linked back to deer contamination in the field. For water and manure are a lot of times what our point sources are as far as contamination goes. When I say manure, I'm including animal feces in this, like from animal intrusion as well. You can also have people who are essentially typhoid Mary, and they're shedding this organism and it's not making them sick. So it can also come from your food handlers as well. As far as how you know, or some of the, once people get ill, I've just provided a bit of information here. I'm not going to spend a ton of time, but I think one of the things that makes this organism, pretty much if you're ever asked what are some of the symptoms of a foodborne pathogen, vomiting and diarrhea are typically up there with this type of organism. It also causes bloody diarrhea. But really what rears this ugly head even worse is kind of the worst case outcomes. So we call those sequelae, and one of the ones that's most commonly associated with this organism is what we call hemolytic uremic syndrome, and that's what causes kids to have kidney failure when they get sick with this. So essentially they have to go on dialysis. You can also have, and this will happen in roughly 2 to 7% of people, and it does tend to be children more frequently than like middle-aged people or even the elderly. Again, you're getting a lot of kidney failure within that case, and sometimes people even never recover, right, from this. So many times they are able to, their kidneys finally get up and running on their own. They may only have to be on dialysis for a few months or so. Overall, we see a death rate once we get HUS, about 3 to 5% of those people. And some types of E. coli within the sugar toxigenic E. coli group, they're more virulent. They are more likely to make people develop this, this outcome. The other thing we see with this organism is what we call TTP, which is basically, it results in strokes. And so within this, we see this affecting elderly more commonly. And again, clearly stroke is an awful case, I would say. So as far as pathogenicity goes, what does it take to make people ill? The infectious dose is very low. 10 cells to 100 cells is just a tiny bit, right? If an animal's shedding this, a lot of times we will see it somewhere up around the 100,000 cells per gram. So that's a lot of organism coming out. The next one I'm going to talk to you just briefly about is Salmonella. Salmonella was one of the ones that was like 1.2 million cases every year. And when y'all think of Salmonella, what do you think about? What food products? Is it produce? Not necessarily. It's poultry, right? It's like, yeah, cook your birds and, you know, don't eat raw eggs and stuff like that. But in fact, we have seen, again, same way with sugar toxigenic E. coli, that being carried out from those animal farming operations and ultimately making their way into point source contamination for produce. There's a lot of different serovars of Salmonella. The group of bad E. coli that we work with is fairly small. It's like roughly 7 types, but this one's fairly expansive. The way that Salmonella is named is a lot of times we'll just shorten this and say Salmonella, and then its serotype. So for instance, Enteritidis. And what's important is that we'll see associations sometimes between certain serotypes in produce. And so it's really important that like Enteritidis, commonly we see that with poultry, where something like Montevideo or Gaminiera, we see more with produce. And that probably only interests people like me who live in a lab for most of their life. As far as where do we find it? Well, essentially we can find it both in our warm-blooded animals, but beyond sugar toxigenic E. coli, we can also find it in reptiles. Birds are really awesome carriers of Salmonella. And it's one reason why we say, yes, try and deter birds from roosting in and definitely defecating on your crops, because many times we're seeing a high carriage of Salmonella amongst these populations. We've seen this strike anywhere from pet food all the way to produce. So it's not just our raw animal products, although they have historically been the biggest issue as far as risk goes. But inevitably, a lot of them get cooked and produce doesn't. So that's why we have a focus coming in. As far as our tolerances go there, again, we're seeing the same pH range that we saw with E. coli, but know that just because it's not able to grow doesn't mean it can't survive at lower pHs. This organism is really salt tolerant, so if you're ever making brines or something like that, not really as important for berries, but if you're ever doing processed foods like vegetables with a brine, it's pretty salt tolerant. Again, our heat resistance, we see the D value right here. I can't see what that is, but you'll be able to see it on the slides as far as what are our inactivation rates around heat. It's not incredibly heat resistant, so that's a nice thing for us. So as far as how people get ill, again, it's primarily vomiting and diarrhea. It tends to last 1 to 3 days, and we see a relatively low mortality rate, but again, we have 1.2 million people getting sick every year, right? So there's a higher caseload. As far as the organism load, we said 10 to 100 for E. coli, right? Well, we're all the way up to more than 10 million to nearly to 1 billion cells that we've seen attributed to outbreaks. We have seen some weirdo outbreaks like with chocolates where we saw a really low infectious dose, but it was theorized that it was 1 organism per gram, but people eat multiple grams of chocolate, so it's essentially they were getting up there, but still we're nowhere around 1 million cells. But typically we need relatively higher numbers of salmonella to make people sick. As far as sequelae goes for salmonella, Reiter syndrome is one of the biggest sequelae that we see. And Reiter syndrome is basically reactive arthritis, and it pops up intermittently, and it's totally debilitating when it does pop up, and it will stay with a person for their whole life, basically. But it can be really bad, and is strongly associated with you having a salmonella infection in the past. For purposes of time, I'm not going to cover a lot of this, but in essence, cooking doesn't activate this organism very well and the toxins that it's associated with. And we see amongst those 1,400 different types of salmonella, a lot of difference amongst antibiotic resistance and things along those lines that can really drive how well an antibiotic treatment may work. For Listeria, I'm going to talk just very briefly because we've seen specifically with frozen foods, Listeria being focused on more recently. We saw Listeria as a huge reason that we're recalling products. As far as Listeria goes, a lot of us actually carry Listeria. It's estimated around 1 to 10% of the population may be carrying Listeria, but it's not making us ill. We are the typhoid Marys in that instance, so no, it can also come from us. It also comes from domesticated animals. We see it associated with similar animals that we see with Shiga toxigenic E. coli. We've seen it in anything from animal feed all the way through to processed foods. Historically, we've said that Listeria is ubiquitous, meaning that we can find it anywhere in the environment. And so it's really associated with soil, what I would say. And guess what? We crop in soil, so it's going to be a risk factor there. As far as tolerances go, it is really heat resistant. In fact, if I was processing milk in Europe, Listeria is the organism of interest that I pasteurize to. Its pH tolerance is not very dynamic, so typically berries are not going to necessarily support growth, but again, it'll survive, and it's also really resistant to salt. Listeria is a bit devious in how it actually makes people sick, because instead of causing vomiting and diarrhea, what it causes is septicemia. And why you have such a high mortality rate, we had 16% mortality rate with that organism, was because essentially it develops into meningitis. And once that occurs, then you have a really poor prognosis. And many times what we see with Listeria, if you look at a Listeria outbreak, I guarantee you the median age is going to be typically above 70. And so in essence, these are people that are just more immunocompromised and their bodies are not able to fight listeriosis as well. It also affects pregnant mothers, and it can pass that placental barrier. And so essentially the same thing would happen into the fetus that mother's carrying, and essentially results in strong incidence of abortion in the 3rd trimester. So if you've ever had a family member that was pregnant, or you were pregnant and they told you not to eat soft cheeses and deli meats, well, it's because of Listeria, but it's really more than just those few food vehicles causing Again, for most of us, Listeria, we actually need to consume quite a bit of Listeria cells to make us ill. And most of us would never get sick from the Listeria we consume. But again, you're not cherry picking who's consuming your product, and the elderly are going to be consuming at the end of the day. This is just talking about, again, that high association with it as a driver for abortions in the third trimester, which is also, I worked with pet food a lot when in previous work, and somebody was like, yeah, don't hurt people's pets and don't hurt people's kids or grandparents. And as long as you can stay out of those things, you know, typically people will be fairly forgiving, but unfortunately Listeria is one of those areas where they share the burden. I'm going to... So I'm going to touch just briefly to kind of prime the pump for Dr. Jacobs and go through viruses just very briefly. So the main thing about viruses, they're only going to reproduce inside of us, or in case there's certain instances where they may have an animal that they can infect. So essentially foods are just a carrier for them. They're never going to grow in that produce environment in the field or in the packing house. They're spread by that fecal-oral contamination route, and they can persist, though, in that environment for a really long time. And they can persist in soil, they can persist on plant matter, they can persist on inanimate, like food process, food contact surfaces, as well as water. The two main viruses that we focus on are Norovirus and Hepatitis A. That is by no means everything that can make people sick on a food product, but is a good indicator. Norovirus, as we already implicated, is the leading cause of foodborne illness, so it's the heavy hitter. A lot of times, like when you do get the stomach flu, it is Norovirus that you are getting. And in essence, what you need to do is just not let those people work who have been reporting vomiting and diarrhea. Again, we see really high shedding rates. When I say shedding, that means the organism coming out in your stool, where, as I said, if you're the king or queen of hand washing, you're still going to have those virus particles on your hands. Hepatitis A is a bit worse, even though we don't see it come up as frequently. In essence, hepatitis A causes the same outcomes that other forms of hepatitis C, for instance, causes, but it's carried by food or water. And in essence, that's going to cause jaundice is one of the symptoms of it. But in essence, someone can start shedding this organism, get contaminated, eat a contaminated food product. And typically it takes about a month and a half, or at least a month, for us to even determine, like for them to start to show symptoms. And the whole time they could have been contaminating your product. With hepatitis, you can actually be immunized. So that is one thing to think about as far as food handlers and things along those lines that may be working in your operations, since hepatitis is one of the things they're focusing on for frozen berries. So a lot of times we focus on personal hygiene, but also don't neglect the fact that these things can stay in the water and things along those lines for quite some time. And we see it more commonly attributed to food, like what I call retail food, but like restaurants and catering events and things along those lines. But again, they're starting to focus more so on processed food as far as the cause goes. They are readily inactivated by heat and by sanitizers. Dr. Jacobs will spend some more time talking about that, but know that that's another thing. For parasites, this is very basic. We have two groups. We have Protozoa and helminths. Helminths are our worms, but Protozoa is really what we focus on. There's a ton of Protozoa that can make people ill, but we typically focus on just a core few. And for instance, for you, it's Cyclospora. These are single cell organisms. They're really commonly associated with water or animal shedding in feces. So again, for you all, Cyclospora is the one to focus on, and Dr. Jacobs will touch on that very briefly. Again, contaminated water is one of the big risk factors as far as produce goes. Personal hygiene, though, also has to be thought of, because again, we can get ill and shed this. Again, heat's one of our best inactivation, but also know that for certain things, like parasites are just kind of more complex organisms. And so for certain food products, we can use freeze-thaw cycles to inactivate parasites. So a really great example of that is in sushi grade fish, right? So we're going through different freeze-thaw cycles within that food product to help inactivate the parasites that we're concerned with there. I've never seen it play out as far as a cycle for something like small fruits, but that may be something that it can work. But a lot of times the freeze-thaw cycle would also really destroy your quality because it has to be slow freezing. So at the end of the day, you're like, well, what do I need to do to prevent contamination? That's what you told us you're going to tell us about. Well, I think water management's key. And I would say that's a big issue because it's not like you can just pull up a different source of water, right? You got what you have what you have. So what I would like to frame it as, for things where we know we're going to be contacting the fruit, our sprays. Can we use an alternate source of water compared to surface water, groundwater, something along those lines where we see lower risk of contamination? Can we reduce application directly to the fruit? So essentially that's our biggest thing with water. We can drip application or again, use alternate sources for our sprays. That would be ideal. For post-harvest, are there any processing steps that we can utilize, even though they're not like a gold star heat kill step? Is there something we can start to utilize, like high pressure processing is something that really came on in the deli meat world, to try and say, okay, we're trying not to cook this again, but we need to try and get this processed so that it doesn't destroy our customer base. Gaseous sanitizer treatments is one area that I would look at. Antimicrobial sprays, I've seen it both applied in the field as well as in the post-harvest world, can have some control there as well. Equipment sanitation is key. Like I said, once you get a contamination event, these things are going to just be, you're just going to be spreading them through if you're not doing a good job with sanitation. And then of course, worker health and hygiene. I think that we all have a pretty good, our head wrapped around that pretty well. But again, for some of these things like hepatitis, is it worth investing in that type of control strategy for anyone who's doing hand contact with your crop? So know your enemy. So I would think if I'm in your shoes and developing food safety plans or GAP plans, I would look at substantiate your decisions on how you spend your resources based upon past outbreaks and recalls. Really focus on that. And I don't think most people will be able to shoot you down if that's what you're going based upon for what you're focusing on. Develop those control strategies, which will hopefully target those organisms, but also know that there's a diminishing return, right? Like you can keep on going, you're never gonna get to zero. So there's always gonna be some inherent risk with fresh produce. Keep an eye out for new information. I would say that viruses and parasites have been skating under the radar, right? So hopefully some of this will be able to get plugged into your food safety plans. I know I'm really close, I may have a minute or two. But does anyone have any questions? Thank you very much for your time.